Hello guys, welcome to the Python series on LearnIn. My name is Nse. Today we are going to talk about augmented assignment operators. Augmented assignment operators in Python are shorthand notations that combine an arithmetic operation with assignment in a single statement. They allow you to perform an operation on a variable and assign the result back to the variable in a more concise way. Let's head over to VS Code and see how it works. Recall that we have talked about arithmetic operations in Python, where we mentioned addition, subtraction, multiplication, division, exponentiation, modulo, and so on. The augmented assignment operator can be seen as a combination of an arithmetic operator and the assignment operator. Remember that the assignment operator is the single equal to sign. In this example, we are looking at the plus equal operator. Plus and equal are put together to form an augmented assignment operator that is used for addition. It's basically the addition operator combined with the assignment operator. So plus sign combined with the equal to sign. Now below here we have the variable x, and x is assigned the value of 5. Right below it, we want to update the value of x, which is 5, by adding 1 to it. That's why we have x plus 1. This x plus 1 is just like writing 5 plus 1, because x in this case is 5. And we are printing the value of x on the terminal. Let's run this code and see what happens. So notice that the updated value of x, which is x plus 1, is printed on the terminal. Here we have 6. That's because x is 5 and 5 plus 1 is 6. Now notice here we have x written 2 times on this line of code. We could rewrite this code such that we do not have to write x more than once. So that's where the augmented operator comes in. I'm going to comment this out and I'm going to uncomment this. Using the augmented operator, we simply say x plus equal to 1. Writing it like this would give the same result as writing it like this, but it is more concise to write it this way. Now let's run this code and see what it comes to. Notice that we still have 6 printed. X is 5. 5 plus equal 1 simply means add 1 to 5. That's why we have 6 returned to us. Just like we had 6 when we wrote it without the augmented assignment operator. I hope that that's clear. Now let's talk about minus equal. Minus equal is an augmented assignment operator used for subtraction. Notice that we have the subtraction operator and it is being combined with the assignment operator. So we have minus equal at the end of the day. Minus equal is used for subtraction. Let's take a look at this code below. We have x and we've assigned it the value of 5. And here on this line, We want to update the value of x, this x variable, by subtracting 3 from x. And so we have x equals x minus 3. Now we could write this code such that we do not repeat x in the same line. That's where the augmented assignment operator comes in. Meanwhile, let's run this code and see, writing it the regular way that we know, x is equal to x minus 3. Let's run this code and notice that we have 2 returned to us because 5 minus 3 is 2. 5 is the value of x here and we are subtracting 3 from it, and so it returns 2. Now let's carry out the same operation, but this time using the augmented assignment operator. So in this case, we simply have x minus equal 3. This is going to subtract 3 from the value of x, which we currently have as 5. Let's run this code and see what happens. We have 2 returned to us as well. So writing it as x equals x minus 3 is the same as writing it using the augmented assignment operator, x minus equal 3. Let's take a look at this example. Here we have the multiplication symbol combined with the assignment operator, and it becomes the augmented assignment operator used for multiplication. Notice that what mostly happens here is that we change the value of x and we still store it back in x. In essence, we change the value of the variable and still keep it in the same variable. Let's run this code and see what happens. We have 4 returned, and that's because our x value this time is 2 and we are multiplying 2 by x. So it comes to 2 times 2. 2 times 2 is 4, and so we have 4 printed here on the terminal. Now using the augmented assignment operator, we have x times equal 2. Writing it this way, x times equal 2, gives the same result as writing it this way, x equals x times 2. But this is shorter and more concise. So let's run this code and see what happens. We have 4 printed, just like we had 4 when we wrote it without the augmented assignment operator. Let's take a look at working with division in this case. The division sign is the / and it's being combined with the assignment operator to form augmented assignment operator for division. We have a value of x as 8. We want to divide x by 4 and store the result in x still. So it's like updating the value of x. So we have x equals x divided by 4. If we run this code, you'd see that the answer is 2.0 because when divisions are done like this, using this single / the results that comes back is usually a float. So that's why we have 2.0. Remember that floating point numbers are numbers that have decimal points. That's why we have 2.0, even though we are working with integers. Remember that integers are whole numbers. The result returned to us is a float because we are using the single /. Now let's take a look here using the augmented assignment operator. We have x divide equal 4. This is the same as writing x is equal to x divided by 4. So we have x divided equals 4. Let's run this code and see what happens. We still have 2.0 returned to us. If you want to carry out a division operation and not have a floating point number returned, then use the double forward slash. So we have an augmented assignment operator for floor division. The operator is double forward slash combined with equal to, which is the assignment operator. Now remember that double forward slash is the operator that is used to perform a division operation that rounds the result down to the nearest whole number, thereby returning an integer result. By integer result, I mean the result will not contain decimal points. Here, remember that our results contained decimal points because we did not use the floor division operator. We used the single forward slash. Now here, because we are using the double forward slash, our results will not come back with decimal points. Here, the value of x is 22. Here on line 8, we are dividing 22 by 5 and still assigning the result to x. So more like we are updating the value of x. Let's run this code and notice that we have 4 returned to us. 22 divided by 5 is 4 and a fraction. Now I have decided to introduce another line, a variable y, and it's going to store the result of dividing x by 5. X in this case is 22. On line 9, we have x with the single forward slash, and then we have 5. So this is going to divide 22, which is the value of x, by 5, and return a result that contains decimal points. On line 9, we have x double slash, and then we have 5. This double slash is the floor division operator. So what this means is that 22, which is the value of x, will be divided by 5 and round the result down to the nearest whole number. So the value that we will see printed on the terminal will not have any decimal points. Let's run this code and see. We have the value of x returned as 4. The value of x is 4 because we are using the floor division operator. That's the double forward slash. The double forward slash rounds the results down to the nearest whole number. Now we have y as 4.4 because here we used the single forward slash, and while running the division operation and the single forward slash is used, the result usually comes back as a floating point number. So we have 4.4 returned. I hope that you get the point. Here on line 11, we have x with the augmented assignment operator for floor division, which is the double forward slash and the equal to sign combined. This line of code will give the same result as this line of code. That's why I have here that it's equivalent to x equal x double forward slash 5. Let's run this code and see. Notice that we have 4 returned to us, the exact same value that we had when we ran this code. For exponentials, we simply use the exponential operator, which is 2 asterisks, combined with the equal to sign, just like this. Here in the example, we have x is equal to x to the power of 3. Remember that exponentiation operator is going to raise a certain number to the specified value. So in this case, our number is stored in x and we are raising that number to the power of 3 because we have double asterisk here. So it shows that we are raising x to the power of 3. X is 2 in this case. So in essence, we are raising 2 to the power of 3. That would come to 2 times 2 times 2. I think I should write that somewhere. Let's have y and let's say 2 times 2 times 2. And this is the expanded form of writing 2 raised to power 3. I'll print y2. Now let's run this code. We have 8 returned in both cases because it's the same thing written in different ways. I'll comment this out. Now let's look at this example that uses the augmented assignment operator. It's going to give the same result as x equals x raised to power 3. Now let's run this code and see what happens. We still have 8 returned because this line of code, x exponential equal 3, is the exact same thing as writing x equals x raised to power 3, just like we have here on line 7. And we have one last example using the modulo operator. Remember that modulo operator returns the remainder when division is done. For instance, we have the value of x as 10 here, and we have the value of y as 3, and here on line 6, we want the remainder from dividing 10 by 3. That's why we have it written as x modulo y. In this case, x is 10 and y is 3. When this code is executed, what we have printed is the value of x. That would be the updated value of x. It's on line 6. So if we run this code, you would see that 1 is returned to us. 10 divided by 3 is 3, and the remainder is 1. So we have 1 returned here. Now let's see an example with the augmented assignment operator. Here we are using the modulo operator combined with the equal to sign, and this gives us the augmented assignment operator for modulo operation. This is exactly like having 10 modulo equals 3 because x is 10 here and y is 3. If we run this code, you would see that we still have 1 returned to us. The same results that we had when we wrote it this way, x equals x modulo y. There will be instances where you would choose to use the augmented assignment operator. It could make the code more readable. This is all that we are going to take today. I do hope that you found today's lesson helpful. If you have any questions or comments, please say them in the comment section. Don't forget to like, share, and subscribe to Learn In. Thank you for watching. See you in the next one.